In Lesson 2, we're going to look at geometric sequences. A sequence with a constant ratio between consecutive terms is what we're going to call a geometric sequence. A geometric sequence with a starting value a and a common ratio r is a sequence of this form: ar squared, and so forth. The ratio of consecutive terms of a geometric sequence is called a common ratio. And in our example that we're using here, you can see that the common ratio is 2. 4 times 2 is 8, 8 times 2 is 16, and so on. When you're given two positive numbers, the positive square root of the product of the numbers is known as the geometric mean. The geometric mean for 3 and 48 would be the square root of 3 times 48, so the positive product of 3 times 48 is the square root of 144, and that gives us the geometric mean of 12. That tells us that 12 is equally spaced between 3 and 48. So if you think about the sequence, 3 times 4 is 12, and 12 times 4 is 48. So 12 is our middle term. And like our first lesson, here's the rules for explicit definition, our a sub n rule here, and then our recursive definition where we write everything in terms of the first term and then follow a rule for the remaining terms. So how do you find the ratios between consecutive terms? Well, that's pretty straightforward. We want to check on the ratio between each term. So if we check 4 divided by 2, that's the second term divided by the first term, and then the third term divided by the second term, and continue on in that manner, what we're looking for is to see if they're all the same. And in this case, that common ratio, 4 divided by 2, 8 divided by 4, 16 divided by 8, all tells us that the common ratio in this particular sequence is 2. Let's look at determining whether each sequence we're given truly is geometric or not. In the first case, 3, 6, 12, 24, it seems that this would be a geometric sequence since the ratio 6 divided by 3, 12 divided by 6, that ratio is 2. And if we practice using that rule for the explicit rule, a sub n is a sub 1 times the ratio to the n minus 1 power, you can see we could write the rule for this sequence as 3 times 2 to the n minus 1 power. In part B, the common ratio, 9 divided by 3 is going to be negative 3. 27 divided by negative 9 is also negative 3. And same for 81 negative divided by 27. So that explicit rule would be the first term times the ratio to the n minus 1 power. And I want to make a note here. You know, there's a difference when you say the opposite of 3 to the n minus 1 power and negative 3 to the n minus 1 power. They're not the same. These are not the same. So you want to be careful. When it's negative 3 is the ratio, you want to include that in parentheses before moving on. On part C, 1, 5, 9, 13, 17, I don't believe that's going to give us a common ratio since 5 divided by 1 is not the same as 9 divided by 5. We could stop there, but if you just want to continue on, 13 divided by 9 and 17 divided by 13, this is not geometric. And then our last example, 48, negative 12, and 3. Negative 12 divided by 48 is negative 1/4. And 3 divided by negative 12 is also negative 4, negative 1/4. So our explicit rule would be 48 times negative 1/4 to the n minus 1 power. Example 2 says to find the indicated terms of the geometric sequences. And here we're looking for the sixth term of the sequence. So to find the sixth term, we first have to figure out that the ratio is -5. We needed the ratio first. And then we need the a sub n rule. So the a sub n rule is 3 times the ratio to the n minus 1 power. And then finally, we can substitute to find the sixth term. We need 3 to the -5 raised to the 6 minus 1 power. And you may want to go grab your calculator. -5 to the 5th power is a little bit large for our brain here. So I get 3,125. And then multiplying that by 6 is -9,375. So the sixth term in the sequence is a large number. For part B, we want the 11th term of the sequence, 64, -32, 16. And first things first, the ratio is -1/2. The a sub n rule starts with 64 times our common ratio to the n minus 1 power, and we're looking for the 11th term. So substituting 11 for every n, that would be -1/2 to the 10th power. And -1/2 to the 10th power, 2 to the 10th power is 1,024. And we have -1/1024, but the power is 10, so the negative will become a positive in that case since we have an even number of factors. And 64 divided by 1,024, that's the 11th power, is going to be 1/16. So the 11th term in the sequence is a fraction 1/16. For example 3, we're going to use a geometric sequence, and again, we're going to need a calculator. When radioactive substances decay, the amount remaining will form a geometric sequence when measured over constant intervals of time. The table shows the amount of adamantium, which is a made-up element, and it's a highly radioactive element initially, and after 2 hours, we want to find the amount left after 1 hour, 3 hours, and 4 hours. So here we have an amount at 0 initially, and then after 2 hours, it's decayed. So first things first, we want to use the mean, the geometric mean, to find what number goes in here. So we can take the square root of the initial term times the square root of the second term, and that will give us the amount in grams after 1 hour. So a sub 1 is the square root of 1,320 times 384. This is going to be our a sub 1 term. And on our calculator, I'm getting about 711.95. So we'll round that amount to a whole number here and say we had 712 grams after an hour. Now we can do the ratio. So finding the ratio between the first term and the initial term looks like 712 divided by 1320. And using our calculator, 712 divided by 1320 gives us a ratio of just about 0.539 repeating. Then I can write the a sub n term, so we'll use r let's use that ratio R as a multiplier, and that'll help us find the remaining terms. So I'm saying we're using it as a multiplier. So with our calculator, the a sub 3 term is going to be 384 times our ratio 0.539393939, and we're going to find the third term is about 207 and 1300ths. So let's round that to make 207 grams. And then for the fourth term, we'll use the 207 grams from the third, and our multiplier 0.53939, and that'll tell us that we have grams remaining of about 112 grams after 4 hours. The geometric mean of two positive numbers, x and y, we said that was the square root of the product of the two numbers. And in a sequence, the formula is going to give us the mean, which will be the a sub n term. And if we were using an explicit rule, it would be the a sub n minus 1 term times the a sub n plus 1 term. Because I'm thinking about counting. If this is the term we're wanting, the term that comes after is one more than the one we're wanting, and the term that comes before is one less than the one we're wanting. This is the mean here. In a geometric sequence, the square of the middle term and any 3 consecutive terms is equal to the product of the other 2 terms. For example, if we look at 4, -8, 16, and -32, if we think about those as 4 and -8, 16, and -32, if you think about 4 times 16, 4 times 16 would either be, if you consider both square roots, since we've got a negative on the 8, it would be a positive or a -8. And then between -8 and -32, think about either square root. In this case, we're wanting positive. So -8 times -32 is going to give us that plus or minus 16. So you can see in a geometric sequence, the square of the middle term of the 3 consecutive terms is equal to the product of the other 2 terms. So the square root of the square of the middle term, 64, is equal to the product of these 2, the square root. In example 4, we're going to find those geometric means, 45 and 80. So again, with the calculator, you want to multiply 45 times 80, and that's 3,600. The square root of 3,600 will be 60. 60 is our geometric mean. Whoop. Somehow I keep clicking on the highlighter. Here in this case, we want to find in between 972 and 12. That would give us this middle term here. So we want the square root of 972 times 12. That's going to give us the middle term, and that turns out to be 108. Now we can find the second term by using, if 108 goes here, we can use 972 times 108 with the square root, and the answer becomes 324. So this is the second term. That's the number that goes here, 324. And then finally, for our last step, we want to find the fourth term. The fourth term. So the fourth term, we'll use 108 and 12 taking the square root of that product, 108 times 12, and that gives us 36. Now we know what the sequence is. 972, 324, 108, 36, 12, and so on and so forth. Okay, so we found the geometric mean, or used the geometric mean to find all of those missing terms. For example 5, we want to write an explicit formula for the sequence and generate the first 5 terms. Here we have the ratio is -1/2, so our a sub n term is the first term times the ratio to the n minus 1 power. So we have our explicit formula, and then substituting for 1, they told us that was given as 12. And for the second term, if you think about putting a 2 here for n, that's 1/3 to the 1 power, and 12 divided by -1/3, or multiplied times -1/3 is -4. The a sub 3 term is going to be 3 minus 1, so we have the second power here, which is 1/9. So 12 over 9 is the same as 4/3. 12 over 9. 3 divides 12, and 3 divides 9. For the fourth term, a to the 4 minus 1 power is cubed, so 27. 12 over -27 is -4 over 9. And then the fifth term is going to work out to be 4 over 27. In part B, a sub n, our a sub n term is going to be 5, and the ratio is 2/10 to the n minus 1 power. A sub 1 is 5, that was given. A sub 2 is going to work out to be 1.0. A sub 3 will be 2/10. A sub 4 is 4/100ths, and a sub 5 is going to be 8/1000ths. So you can do those with your calculator, and they're pretty straightforward. And that, my friends, is the end of Lesson 2 in Chapter 9.